Let's do some problems involving parabolas. In particular, given an equation, I want us to be able to find the vertex, focus, and directrix, and be able to graph the parabola. But before we get there, let me refresh your memory on our standard form for the equation of a parabola. These parabolas are all sitting with the vertex at 0, 0. Remember that the equations will look like this, and the focus for each of them is always inside the parabola. So for example, on this first one, the focus would be up here at A, and the directrix is on the opposite side, so it would be here at y equals negative A. Similarly, the focus would be here at negative A because it's inside the parabola, and the directrix would be here at y equals A. Again, the distance from vertex to directrix and vertex to focus is always A units. So the same thing happens when we have our parabola oriented this way. Now the focus would be here at A0 as an ordered pair, and the directrix would be over here at x equals negative A. And on this last one, of course, the focus would be here at negative A, and the directrix would be right over here at x equals positive A. If we move the parabola off the origin, it gets shifted off the origin much like our other conic sections do. The vertex kind of plays the role of center. We don't have a center with a parabola, but the vertex plays that role. So if I were looking at this particular equation, we know it has the look of a parabola. That equation is the standard form of a parabola, but now the vertex is going to be at HK. Again, shifted off the origin in the same way we do it for our other conic sections. So if I were going to graph this one, I would make sure my vertex were at HK. I don't have values for those, so we'll just put H here and K here. Your X, remember, will always, the X coordinate of the vertex will always be with the X, and the Y coordinate of the vertex will always be with the Y. So we would put our vertex right here, and because this is an X equals Y squared graph, we know that the graph would open either right or left, but because we have a positive coefficient, we know it opens to the right. So my graph for this one would generally look like this. I don't know how wide or narrow it is, but in general, our parabola would look like this, with our focus being here and our directrix over here, again with this being A units and this being A units as well. Let's actually do some problems now. So the directions will be, for each of the problems we do, find the vertex, focus, directrix, and graph. And we'll start with a basic one. We'll start with y squared equals 28x. And we see that the vertex is just going to be at the origin because it didn't get shifted off the origin. So let's just jot that down. The vertex is at 0, 0. But now I need to know what A is in order to determine where the focus is. So I set 4A equal to the coefficient of X, the coefficient of whatever this linear term is. So I see that A is 7. So for this particular graph, I'm going to put my vertex here at 0, 0. We have an x equals y squared type, so I know it opens to the right. I just draw myself a little bit of a parabola so I can tell where to put the vertex, or excuse me, where to put the focus. Because the focus is always inside the parabola, I know I'm going to move 7 units to the right. So my focus is going to be right here at 7, 0. So let's write that down. Focus is at 7, 0. Now the directrix is on the other side, again, A units away from the vertex. So I move this direction A units. And remember, the directrix is a line, so I need to make sure I represent the directrix as a line, not a point. So we have a vertical line. We know the equations of vertical lines look like x equals a number, and of course this one is going to be at x equals -7. So we've found our vertex, our focus, and our directrix. Now let's graph it. We do know it opens to the right, but we don't know how wide or narrow it is. And here's where the lattice rectum or focal diameter comes into play. Remember, the distance across the parabola through the focus is equal to 4a. In other words, the distance across the parabola through the focus is equal to this number right here. So across the parabola, it will be 28 units. So we divide that in half. That means I'm going to go up 14 and down 14 for a total of 28 across this parabola. And now I can draw a nice, decent parabola through those points. And I have it sketched. Let's do another one. I thought we would do our very familiar y equals x squared, because we often look at that as its properties of a function, its properties as a function, but let's look at it as its properties of a conic section. I like to write it as x squared equals y. Now you don't have to, but I just in general write them in this form with my quadratic term on my left and the linear term on the right. Unnecessary, but I just feel more comfortable if I do that. Let me remind you that the coefficient here would be 1. So our 4a in this case is equal to 1, which makes a equal to 1/4. So let's roll through the information that we know about this one now. We know the vertex is at 0, 0, since it was not shifted off the origin. Its focus, let's see. If I draw a piece of the sketch, it will help me find it. We know that it's a y equals x squared type. That means that it opens up or down. Because this is positive, we know it opens up. And we know the distance from the vertex to the focus is 1/4. So let me make my scale look like this. So 1/4, up 1/4 would be where I would find my focus. So as an ordered pair, that's 0, 1/4. And the directrix, right, we know, let me just sort of roughly draw it here. The directrix is on the other side of the parabola in the same distance away from that vertex. So it looks like this. This time we have a horizontal line, and we know equations of horizontal lines are always y equals a number. And the number in this case better be a -1/4. Now again, we have this parabola, and because it's y equals x squared, you probably know exactly how it looks. It would go through this point 1, 1. But let's find the endpoints of the lattice rectum so that you have practice seeing how that works. The distance across the parabola through the focus is equal to 1. So the distance across the parabola through this point is equal to 1. So I split that in half, and I go a half this way. And I go a half this way. And now I know my parabola looks something like this. So again, this lattice rectum right here is this segment. Again, its length is called the focal diameter. But we know this length is 1, from -1/2 here to +1/2 here. Let's do another one. let's do one that's been shifted off the origin. So let's jump in with the vertex first. It's already in standard form, so the vertex is looking at us. Remember, you look with the x value to find the x coordinate of the vertex, and you look at this term with the y to find the y coordinate of the vertex. So it's always x minus the x coordinate, so that would be x minus -7, or in other words, it's always the opposite of the number you see there. So we know the vertex would be at -7, comma, -4. So let's sketch that. Let's see. -7, -4. We'll put the point right here. We have a y equals x squared type. It's a function, which we know opens down because of this negative. So I'm just going to draw that just very lightly to help me remember which way it's opening, because now I need to find the focus and directrix. So again, we set 4a equal to 8. So a is equal to 2 in this particular problem. So the distance from vertex to focus is 2 units. So from here, I'm going down 2. I'm at -4. If I go down 2, I would be at -6. So my focus is right here at -6. So let's see, the ordered pair would be -7, -6. And the directrix is on the opposite side, and of course up 2 units. So right here, and if you move up 2 units from -4, you're up here at -2. So we have a line that is at y equals, so let's write it this way. Directrix is at y equals -2. Now, in order to have a decent graph, I'm going to use this 4a equals 8 to tell me how far to go in each direction for this parabola. So across the parabola through the focus, it's going to be 8 units. So I move 4 in this direction and 4 in this direction. So let's see, if I'm here and I move 4, where does it put me? At -3. And at -7, I move 4 in this direction. I'm at -11. And notice from -3 to -11 is 8 units. So I'm going to put a point here, and I'm going to put a point here. And then I would have a respectable parabola that reflects this particular graph. Let's do one last problem. Because sometimes the equations don't come in standard form. But don't forget, our goal is to make the equation look something like this. I'm going to put the quadratic term on the left and the linear term on the right. And we do need to make sure that we complete the square with whatever is quadratic, whatever is to the second power. So in this case, it's our y that is to the second power. So I know I'm going to have to complete the square with respect to y, because we have a y squared and we have this other y term over here. So let's gather those terms together on the left. Y squared minus 12y. And I want everything else on the other side. That means I'm subtracting 20x and I'm subtracting 76. Now, in order to build a perfect square here, remember we take half of this number and square it. So half of -12 is -6. -6 squared is positive 36. So I add a 36 here. And of course, that means I add a 36 over here as well. So I have y minus 6 squared equals -20, -20x minus 40. But I want to factor out the coefficient of this linear term. Whatever that coefficient is, that's what I need to factor out, because I want it to look like this. So I have y minus 6 squared equals, and I factor out negative 20, and I have x plus 2. And now we can roll through the process of finding the vertex, focus, and directrix, just the same way we did on the previous problem. So let's do it. Let's start with the vertex. X coordinate of the vertex is here, y coordinate is there. It's the opposite of this number, so the vertex is at negative 2, comma 6. We know we have an x equals y squared type, so it's a parabola that opens either right or left, but because this negative, we know it opens to the left. So let's see, we'll do this, put our vertex in at negative 2, 6. So here's our vertex. And again, I just lightly draw it so I keep in mind it's opening to the left so I can figure out where the focus is. I set 4a equal to 20, right? Equal to that number, so a equals 5. So I know the distance from vertex to focus is 5 units. So from here, I'm moving 5 units this direction. That would put us here at negative 7. So the coordinates of this focus are negative 7, 6. And of course, for the directrix, I move 5 in the opposite direction, so it's over here. Let's see, this was 5 units, this is 5 units, and if I'm at negative 2 and I move right 5, I would be at positive 3. So my directrix is, let's see, it's a vertical line, so it better be x equals positive 3. And last, I'm going to use this information to determine how wide or narrow my parabola is. So the latus rectum will be of length 20. So across the parabola through the focus, it will be 20. Oh, I didn't leave very much space for this. So this is 6. So I'm going to move, I have to go across the parabola 20 units. That means 10 this direction and 10 this direction. So let's see, we'll go up here 10 and down here 10, right? So we're way up here at 16 and down here at negative 4. And draw our parabola that goes through each of those 2 points. And we have that graph completed as well.